Here's one I picked up at the flea market this morning. Don't even really know what brand this is. It's an AM shortwave radio phonograph combination from sometime in the 1940s. And I really don't think there's much hope for this. Thing looks like it's been sitting outside for who knows how long, or possibly inside of an old damp barn, but I bought this more for parts than anything. I guess it could be redone if I was determined enough, but really don't have the woodworking skills to do this. So this is likely going to be an EOLer, at least for the cabinet anyway. There's the record changer, old 78 RPM changer from the 40s. This looks like possibly a Seaberg built changer, but I'm not sure about that. And here's the chassis. I have no idea who made this. I see it has a 3-gang tuning condenser, so likely has a tuned RF stage. All of the tubes except for the output tubes and the rectifier, which is missing, are octal based tubes. The output tubes and the rectifier are standard octal tubes. Have a push-pull output stage, probably 6V6s or 6F6s, probably 6F6s. Have our 12-inch electrodynamic field coil speaker. But yeah, it's a shame this thing's in such bad shape, because this looks like a nicer unit in its day, but as warped up and messed up as this cabinet is, I think about all it's good for is parts. And here's the chassis removed from the cabinet. It's amazing, the chassis looks in very good shape in comparison to the cabinet. And here's the speaker. It wanted to be a little stubborn about coming out, but the speaker mounting board was so rotten that I was able just to yank it out. And cone-wise, at least, it looks in decent shape. And this chassis is a Sparton, according to what's on the dial, after I cleaned a little bit of dirt off of it. And here's the underside of the chassis. Looks in pretty decent shape. And I see it has flywheel tuning, so this was a fairly nice unit in its day. Like I said earlier, it's a shame the cabinet is totally trashed. But I might play around with this chassis just for the heck of it. See if I can get it going again. Yeah, one thing I am noticing that's a sign of cheapness is this puny little output transformer on here. You'd think with a push-pull 6F6 based amplifier they could have put a little bit bigger transformer on here for better frequency response, but it is what it is. Something to play around with and or to use for parts. And here we are with everything removed: the chassis, the loop antenna, the speaker, and the record changer. Have a look at the underside of this record changer. Looks pretty well made. Okay, we now have the chassis up on the bench, taking some preliminary measurements while my Chinese light continues to give trouble. You might remember a previous video I did about that light. Well, anyway, I'm about ready to rip it out of the ceiling and go out and find a better one. Okay, anyway, we are testing the speaker field coil. That's this device right here. It serves as a filter choke in the power supply, as well as provides the magnetic field for the speaker to operate. And we're reading 757 ohms, so I'd say that's good. Now we'll test the audio output transformer. We're now checking the audio output transformer. It's a center tapped transformer, since this radio uses a push-pull output stage. Across one half of the winding we're reading 1.2 megohms, so that's definitely not good. And across the other half of the winding we're reading absolutely zilch. So this audio output transformer here is going to have to go. Not going to spend any money on one, so surely we have a push-pull audio output transformer here somewhere in my junk that we can try. Okay, I just returned from Lowe's with another fluorescent light, of course another Chinese special. So we'll now hang this one up, and if I'm lucky, maybe I can get 30 days use out of it before it starts acting stupid. And there you go, made in China. There's the proof. And to think I've got fluorescent light fixtures in my basement that are 50 years old or older and still working. Okay, we're back in business for the moment with in the lighting department. And if I thought this light would be any degree of reliable, I'd wire this thing into the junction box. But I'm sure it'll die in short order, so it'll be just that much easier for me to unplug it from the wall socket instead of having to unwire it from the junction box. So we'll just leave it like this. Alright, now that excitement is over, let's see, where were we? We were fixing to try to find a replacement audio output transformer for this radio chassis, so let's get back to that. Okay, I've located another audio output transformer removed from that mid-50s Magnavox mono amplifier that you see on the floor. And I know some of my audiophile friends are probably hitting the dislike button right now that I would tear up a Magnavox amplifier, but you know, this old amplifier came out of an old cabinet model record player that was too far gone, and that's the reason I saved it, was for parts. I didn't buy it or I didn't save it in order to flip it on eBay for $100. I needed the output transformer off of it, and it happened to be the closest thing I could get to, so there you go. And it's likely a better output transformer than what was on here originally. And as you can tell, I didn't make any effort to make this look neat, since this is something I'm just playing with anyway. If I decide to do something worthwhile with this project, then I'll neaten it up a bit. But for right now, we got the speaker taken care of. Now we'll move on to the radio chassis. And now the next order of business is to replace this old rotten power cord. Okay, we have our power cord tacked on, and we have continuity across the primary winding of the power transformer. Now we need to dig up a rectifier tube, but before we do that, this will be as good a time as any to test the power transformer and make sure it's putting out the right voltage. And checking across our high voltage winding on the transformer. 700 volts, pretty stout little transformer there. And obviously our 6.3 volt filament supply is working because the tubes are glowing and the dial lights are burning, so that confirms that. And we have 5.5 volts on the rectifier tube filament, so as far as I'm concerned, this power transformer is A-OK. Okay, I'm glad I didn't get hasty and just pop a rectifier tube in here. I'm glad I made one other little test here, because we would have had a problem. I'm checking between the B+ output of the rectifier tube and chassis ground, and on our trusty digital multimeter, we're reading 1.5 ohms to ground. So that tells me we have a short somewhere. Now, if I were to put a new rectifier tube in here, we could, well, most likely we'd burn up the rectifier. In an extreme circumstance, we'd burn up the power transformer. So, let's find out why we have basically a direct short from B+ to chassis ground. Okay, exploring our possibilities here of what could be shorted. We have one lead coming from the rectifier tube socket over here to this filter capacitor. And then we have another lead coming from this exact same point over here to the speaker socket. Right there where my finger is. And there doesn't appear to be anything else connected there. And since I have the speaker disconnected, unless I'm missing something, that pretty much leaves this filter capacitor as our prime suspect. So let's unsolder this lead here and test it out. Okay, we have our filter capacitor disconnected. Now let's remeasure and see if our short went away. Let's see, there we go. And what do you know? No short. Testing from the disconnected filter capacitor, I read 1.4 ohms to ground. So those of you who say you've never seen a dead shorted filter capacitor in a radio, well, now you have. And I'll have to admit that in 20-something years of doing this, I've ran into very few electrolytic capacitors that were actually dead shorted. Now, I've seen them leaky enough that would cause a problem, and I've seen them that wouldn't actually check shorted or leaky on an ohm meter, but when you applied voltage to them, they acted up. But very few of them have been dead shorted like this one is. I remember years ago, a church here in town gave me a mid-80s 25-inch Zenith TV. It was one of those wooden cabinet jobs with the wooden cabinet table model jobs. I think it used a 9-181 main board and a 9-186 high voltage board. Well, that particular set would groan and grunt and acting like it was trying to come on, but it wouldn't completely fire up. All B+ voltages were low, and it turned out the problem was a dead shorted electrolytic capacitor inside of the tuner, inside of the electronic tuner module. I don't remember the value of the cap, but it was something like 1,000 microfarad or 2,200 microfarad at 35 volts or something like that. But that capacitor was dead shorted. I replaced it with a good cap. The voltages came up. The TV worked perfect. Now, let's address this capacitor. Okay, the electrolytic filter capacitors have been replaced. And I'll just say that this is not my standard way of doing things. Had this been a radio that I was restoring that had a nice cabinet, I would have used terminal strips and made this look neater. But since this is something that I'm just playing around with and will probably eventually end up getting parted out anyway, I've just more or less hacked them in here. Although this still looks better than some repair jobs that I've seen come through here. Now let's find a rectifier tube, see what happens. Okay, I now have the filter capacitors replaced. I have located a rectifier tube. I went with a 5Y3, judging by some schematic diagrams I saw to other similar radios. But if we have to go to a higher current 5U4 tube, we will. I could have started out with a 5U4, but the filament current for a 5U4 is greater, and that might stress the power transformer. So we'll go with a 5Y3 first, but right now we have the radio powered up, and I'll slowly bring it up on the variac, see what happens.
Well, here I am.
And there you go. We are working. The Barn Fresh Sparton radio chassis is now up and running.
Wow, that woman could be so mean.
So basically all we had to do to get this thing going was replace the audio output transformer, which was probably caused by the elements of nature, the power cord, the filter capacitor, and the rectifier tube. And I feel like the filter capacitor is what killed this set to begin with. Now, if we were going to get serious about restoring this chassis, I would replace every capacitor in it and go through and check things with a fine-tooth comb. But our objective here is to only get the radio operational, and we have done that. Okay, that ought to wind it up for part 1 of this video. In part 2, we will take steps to improve the performance of this chassis, just so we can have some more fun with it. But yeah, this is not too bad for something that's been in the barn for probably 50 years. Okay, thanks for watching, and more to come later.